Good evening to one and all present here. Myself, Shomo Roy, and Joel Viju will be presenting Smart Feeder, an intelligent assistive robot for enhanced mealtime independence for the seed grant for year 2024-25 under product development under the guidance of Professor Buddhaditya Bhattacharya. So the outcomes of the previous year's seed grants are shown here. So we have done a constructive study of the existing architectures in the world, and thereby we have come up with 10 papers which talk about the feeding robot which we are going to build, and also 3 patents over the existing architecture. And after analyzing the 10 papers and 3 patents, we found some significant research gaps. One of them was using standard utensils for adaptability, using PET spoons for versatility, because we need unique tools so that we can attach for a robot and use them easily. We need to do path planning for the robot so that it can accurately lift food and place it in the human's mouth. We need a more intuitive and easy user interface so that the information can reach the user very easily through visual methods. We would also want to make this open source so that different users can use different types of food and have consistent performance. We also want to ensure that the particular system has to be robust and safe for a human, and the human should not be injured in the process of operation of the robot. Then we also wanted to look into the real-time error handling mechanisms, because in case the robot goes out of control, we should be able to halt the robot to ensure that no particular damage is done. We also want to develop novel feeding mechanisms so that we can feed users with great ease and less amount of discomfort. We also want to make our solutions cost effective so that they can reach a wide variety of users instead of being stagnant with rich users who can afford such technology. We also want to understand the user's intent and facial gestures to understand what food they would like to have and what they wouldn't like to have, which would be good for the future analysis so that we can improve the feeding techniques. Coming over to the problem statements that we have analyzed, that we want to improve the quality of life for individuals who have arm based disabilities by making this kind of robot so that feeding becomes much easier. We have also used gesture sensors for ensuring safety by detecting the presence of a human. We have used a special flexible spoon using PET material so that we can move it close to the ball and use it for lifting food and to get good feedback using intelligent control systems and using state of the art control algorithms. We also want this entire system to be independent where they can learn from humans operation and perform the task all by themselves. We also plan to make this setup cost effective by using readily available materials in the market like servo motors, common stand, and PT spoons to keep the cost low so that we can create greater impact and greater usability among users. We also want to aspire to create a transformative impact on people who have such disabilities. Our objectives are to design a 6DOF manipulator for feeding patients who are suffering from Parkinson's disease. We also want to use a special type of spoon called PET spoon, which is made using a particular material called polyethylene tetrafilate. We also want to integrate the manipulator with state-of-the-art operating systems for control called ROS, Robot Operating System, and control algorithms like PID for precisely lifting up the food and to feed the user. We also want to integrate gesture sensors like Adafruit to detect the presence of the human and then proceed with feeding the human. We also use a high resolution camera to detect the mouth, whether the human's mouth is open or closed. And we also have gesture based control where a simple nod of the head would mean that the person doesn't want to consume the food, and a nod upwards would mean that the person would like to have this particular dish, for which we make the manipulator universal for users. We also plan to use state of the art quick and fast communication protocols like USART and SPI for controlling analog sensors like the gesture sensor. And we also use a PID controller by taking the gesture of the human as a feedback. We also want to develop an intuitive app on a mobile phone so that it can alert the users regarding the robot's operation, and in case of emergency the human can stop the particular robot. We also want to test this in a real world scenario in a hospital so that we can understand how patients would react to a feeding robot and then iterate over the future prototypes. Our research plan consists of this methodology where we would detect the gesture using Adafruit's gesture sensor, then whether a person is nodding for a particular food. After analyzing the pattern, we would perform the scooping action to lift a particular food item. Then we would use the camera to detect the position of the human mouth so that we can plan a trajectory to put the food in the user's mouth. Then we also need to perform height adjustment for the robot so that it can plan a smooth path for lifting the food so that the food does not fall in the or during the operation of the particular robot. We would also need to check for the time limit for which the user is being fed, and after processing the position of the mouth, if the mouth is open, we can move the spoon in X direction to feed the user. And if the mouth is closed, we can put a time limit to return back to the original state to the ball and then continue the same action again and again. So the expected outcomes is that we want to develop this 6 degree of freedom manipulator which can help people who are suffering from Parkinson's disease. We also plan to have good documentation which would consider the CAD models of the design specifications and assembly instructions using the manual and the GitHub link which we would be attaching with the same. And the user interface would be a well designed app with animations so that the user can get a good idea of the operation of the robot and can halt the system if anything goes wrong. So, talking about the budget, we are going to use a 6 degree of freedom arm which is called DOF bot AI vision arm. We would use a gamepad or a controller to manually override the robot in case anything goes wrong. For the brain of the robot, we use the Raspberry Pi board We would also be using a Lenovo web camera to detect the gaze of the human's mouth. We would be using a gesture sensor to detect the gestures of nodding shown by the human so that we can analyze the specific choice of a particular food. We would be using a GPU for doing image processing of the mouth using OpenCV. So the timeline that we propose is we propose a 2-year timeline with 4 phases. In the year one, in phase one, we would do the ideation and brainstorming by taking feedback from the technical and hardware details, and also by consulting doctors over the present challenges in the field and how they can be solved using our prototype. We would also be simulating the robot to analyze different setup environments and to plan the motion of the particular robot to prevent any kind of action which would not be permitted for a human. Then we would proceed with the documentation of our work. Next, we would proceed with training our deep learning based algorithm called YOLO V10 to analyze the gaze of the mouth, and we would want to fine tune this model so that we can detect the gaze of a human's mouth with high level of accuracy. And we would like to test this prototype before proceeding to the next stage, and thereby we would also document it. In the year 2 phase 1, we would make final changes in the code and fine tune our control algorithm and integrate the camera, the control system, and the manipulator together. We would also deploy it in real world environments like hospitals to get feedback for the same and to iterate over if any improvement or changes would be required. In phase 2, we would proceed with the final documentation and the final stage of the robot, and we would compare the results of how accurate our robot works compared to the existing ideas of how a human or a nurse could be present 24/7 to feed a particular human. Thank you.